Okay, thank you. So it's a pleasure to be back at NoBug again. I haven't been for quite a while. I was actually involved in the very start of NoBugs. Although interestingly, I didn't actually go to the very first meeting because I had to go to another meeting, which was in Grenoble at exactly the same time on exactly the same dates. This was called the OTRAN meeting, and this was actually one of the early steps on the way to ESS. So this is a good indication that things take a long time, which I'll be getting back to in my talk later. So what I'm talking about now is very high level compared to all the other talks I've heard at NoBugs so far, but I hope it's useful and makes some useful points. And it's about what we call now the Ada Lovelace Centre. Just to explain, UKRI is now the UK, if you like, top funding research council joint organisation within which STFC, Science and Technology Facilities Council, is a sub-research council. So we have funding lines that come from both of these, both from the top level and within STFC. But STFC is responsible for running the UK large national facilities. So the idea is that Ada Lovelace Centre is a centre providing skills and expertise for research data management, research software engineering, very specifically focused on the requirements of UK central facilities. So that's Diamond, ISIS, and the Central Laser Facility, and the Scientific Computing Department, because they're also a data generator because they run a lot of simulations, for example, which links into what the facilities do. The idea for ALC has been around for some years. We originally launched the idea in 2016, but at that point, we only had a very small sort of trickle of funding out. Currently, we have a project portfolio under the ALC brand name of about 30 projects supported by 20 FTE. So that's the current level of activity. But as I'll indicate, what we need to do is ramp that up. And I just show a slide here, which was from my presentation at the very first ALC meeting, again in 2016, making the point that three important aspects here. One is investment. This what we want to do costs money, and you need money to do it. Collaboration, that by collaborating cross facilities, cross capabilities, then you get better value for the money you have, and you can go faster. And particularly at that time, about professionalization. I think if you've been at the very early NoBugs meetings, you'd have realized that in the time since then, the software and data at facilities have become very much more professional from the professional point of view. It's really very much more professional. It's not the amateur scientist doing things any longer. It's a very professional approach because of the scale of thing that we're now dealing with. So we now have funding to properly establish ALC and significantly ramp up the activity from, as I said, about 20 FTEs worth. An important point to make, and actually linked to the previous presentation, was that ALC itself is not going to own or operate high-level, high-performance computing or data storage facilities. It will use resources provided by other UK initiatives. That might sound a little bit random, but actually we're very tightly coupled into those initiatives, and they are aware of what our needs will be, and it's part of their responsibility to provide them. But ALC is just people dealing with software and data. Structurally, to start with, at least, we will set it up as a program within the Scientific Computing Department, and we'll have core dedicated staff, but also staff matrixed in from scientific computing and the facilities. But it will have a formal governance structure. So from that point of view, it will look at like its own entity. So why do we need ALC? I think the previous presentation showed that very clearly for APS, for example. So the facilities produce increasingly large volumes of data. It's not just very large data sets, but it's also very large numbers of data sets, very many different experiments, different simulations, and an enormous breadth of scientific area that covers. And particularly for us, the recent facility developments that have been funded, so this is Diamond 2, this upgrade of the Diamond lattice. EPAC stands for Extreme Photonics Application Center, so that's a big new laser facility. Endeavour is a new ISIS instrumentation program. And particularly because there's a lot of increased emphasis on imaging, that's going to produce a further increase. But I'd note these facility developments, between them, that's getting on for €500 million worth of investment. and the investment within that goes into the dealing with the software and data is very small. And you know, that for me, that is a problem. It's not appropriate, because it's not scientifically or cost effective to generate all this data if you can't actually use it and exploit it. And more than that nowadays, because of the requirements of environmental, say, sustainability, so the move towards net zero, the energy requirements to generate and store the data, and actually now the cost, because that's gone up enormously, they're really large. So if you're not going to use the data effectively, this is just not sustainable. So we have to invest a lot more in actually the exploitation of the data we produce. And this is a little side note, but I just point out that particularly in physical science and engineering, if you look at the downstream use that's made of aggregated data, so databases essentially, for example, through data mining, is actually really minimal. And despite initiatives like, say, the materials genome in the US, which was, I don't know, that was 12 years ago or something that was launched, really physical sciences hardly uses databases at all, and we have to really improve on that a lot. So overall, it's not a problem that can be solved in a few years by a few people. There's tended to be the idea for quite a long time that you hire a few postdocs and they write some software and suddenly everything is solved. This requires large scale and long-term investment, and it also requires very specific skills. And I mentioned the professionalization of software, so that gives again, it's not just scientists doing this now, it's a very wide range of skills. So if you're going to do this at the right scale, and you want to attract, develop, and retain those skills, you need to have a coherent and sustainable organization. You have to have career structures for people. I think that's been mentioned. And obviously the facilities themselves will benefit both scientifically and financially from the scale and the synergies across that scale. So to give an idea of what I think the scale needs to be, the example I'm using is the European Bioinformatics Institute. So this is an institute in Cambridge in the UK. It's part of the European Molecular Biology Laboratory. And it's really been a world leader in data and software for biological applications for several decades now. So EBI has 500 staff of order who support databases and software for the user community, and 250 staff carrying out research using that data. But the user community is much broader than that. So that's 500 staff, but they only deal with two types of data, crystallographic data and genomics. And both of those are really well structured. So in some sense, it's quite simple. They're just expanding into imaging because of the explosion in electron microscopy for crystal structures. And they're already recognizing that's a big challenge, even relative to what they're already doing. And then if you look at the facilities we're talking about, they deal with a much wider range of data, including imaging and actually crystallography. And most of that is much less well structured. So at some level, you're already saying that you need something of the scale of at least several hundred people, if not more, just to deal with the problems of the SDFC large facilities. But we're now trying to recruit and retain that sort of staff in a really competitive skills market. So that is going to be a problem. And another reason for going to an organized institute of this sort is that scale, visibility, and reputation will be key factors in being able to recruit people and to keep them. And that's something EBI manages to do, for example. So key points, ALC is supposed to maintain a critical mass of relevant expertise. That's the absolutely important thing. The work we then do will sit within a project or program project portfolio. That's got to have a long-term strategy. It's not just a short-term collection of bits and pieces. Some will be facility specific, some will be generic cross facility. Education and training, of course, will be an important role. I think it's important that in common with facility scientists, ALC staff can do some of their own research. They're not simply providing services, because again, this is an important factor in staff retention. It could also bid for external projects and grants, do collaborations, etc. But again, it's very important that you stick to the idea that most of the portfolio supports the facilities. That's its core purpose. Major themes are likely to be imaging and reconstruction. Fairly obviously, this is something that goes across all of the facilities, and that's in the most general sense. Simulation and modeling for data interpretation, where we have a lot of strength in the UK. Machine learning, as has already been mentioned many, many times, that's one of the ways you think that we can get over some of these large data set bottlenecks that we have. All the issues of data and metadata management, and there's a big lot of issues there. The whole move towards fair data, but again, to get fair data requires significant investment. It doesn't, you can't just make data fair on a shoestring. And then also providing data analysis services. So although we won't run the computers on which the services, sorry, we won't operate the computers on which services run, we nevertheless have to provide the data analysis services. So IDaaS is data analysis as a service. We have to provide those capabilities for what we're doing. And a theme, an overarching theme should be that all the projects should sort of develop what I'm calling cross-theme services. So the idea is that instead of just saying, I want to do a project within this particular theme, you then have to think, okay, if I want to analyze this data, how am I actually moving the data? How am I managing the metadata? Does it have a long-term, is it fair? Does it have a long-term life after that? So you've got to think through the whole problem. This means we need a lot of skills. You don't have to read the list here, but as I said previously, there are a lot of different types of skills you will need. And so actually putting this together is not going to be a trivial thing to do in a short time. So where are we starting from? Well, I would say that no country has solved this problem. I mean, you just had a talk from the APS about how they're approaching it, etc. And everyone's recognizing it's a big issue. I don't think STFC are behind. We've been doing a lot of things in this area for a long time, but not at sufficient scale. We certainly have a well-established scientific computing department, which is very important because they have a broad range of existing skills and a very strong track record. So, for example, the UK collaborative computational projects have been going for some of them for decades and providing software services out to wide communities. And we have a track record of other early collaborative initiatives such as open data policy and so on. We have a relatively new but has been rapidly developing machine learning group that's going very strongly now. And we do have several years of existing cross-facility projects, as I indicated, already supported under the ALC name, but now we need to scale up. Opportunities for collaboration are quite large. There's some on the national scale, the two at the top, which are actually funded by other research councils, but actually run through the scientific computing department. Some of the opportunities, so the link to Diamond, which is actually a link to SED ALC that was just mentioned in the previous talk on machine learning. I believe that has actually just recently received some funding to go ahead. Lots of collaborations in Europe. One of the problems of the UK is, of course, at the moment we're not a member of Horizon Europe, and we're not a member of EOSC, so we're a bit on the sidelines there. But we can collaborate through other things like LEAPS and LENS and Laser Lab Europe, which are not themselves EU activities, and so we're tied into all of those things. So there's a lot of collaboration possibilities here, which we have to make the most of. So what's next? We have flat funding for the current financial year. That's fine. That keeps our current project portfolio scale. And then from next financial year, our funding will ramp up. We're hoping for additional, I think very likely we'll get additional funding from the UKRI line to get more rapid expansion. So we're in the process of establishing a governance structure. Then we agree the goals, long-term implementations projects, set up the organizational structure and start recruiting. And so the aim is at least at the scale of 100 FTE within 5 years, and then maybe 300 FTE within 10 years. That's possibly optimistic, but this is the scale you need to be thinking about. I finished with a slide. So when I joined ISIS in 2002, I got the agreement that we could spend 5% of the cost of the new instruments on Target Station 2 on software. That's not control software or anything, that's software for data analysis. And that was what allowed us to launch the MANTID project, which has actually been relatively transformative in neutron scattering data analysis over the years. But at the same time, I also said, well, we need to do all these other things. As well as MANTID, we need to, and the words have changed now, you call them different things, but it's the same principles. But I've realized over the years that the scale of this issue is sufficient that you cannot deal with it just by a percentage of your hardware investments. It is of the same scale as the hardware investments. And if you add it onto the hardware investments, it always tends to become the contingency, because people will say, well, I have to build the instrument first before I need the software. And so I put all the money into the instruments, and oh, by the way, I've got nothing left for the software. So this is one of the reasons for separating the ALC idea out from the facilities themselves and from the investment going into those facilities, is because it has to be done at scale. I think we have the opportunity now. We have that foot in the door, and we hopefully can ramp up over the next few years. So I think that argument has been accepted, but maybe have to come back in 10 years' time and say, has this really worked? Thank you.
Thank you very much, Robert. Do we have questions? Yeah, Andy.
Yeah, Robert, what is the overlap with the Turing Institute, which is close by?
Okay, the Turing Institute is actually, it's slightly bizarre that the only real, I would call direct scientific research that the Turing Institute does has actually been going into funding some of the Ada Lovelace Centre work. The Turing Institute itself is mostly about the applications of AI and ML and algorithms, etc., for industry. Right, it's very industry focused. So it sounds as if the Turing Institute is an academic research institute, but it's not. Or it's academic research on behalf of industry.
Thanks.
And a question from me. So the Ada Lovelace Centre is kind of sees that as a service to the facilities. It's not kind of the idea that there would be direct end user, I don't know, support or contact with the users that carry out the experiments directly?
I suspect that may well happen because, of course, if the expertise on certain things lies within people within the Ada Lovelace Centre, then they may well provide support out to facilities or facility users on particular pieces of software. We have to see how that goes. I mean, that's kind of been happening for a long time through support given to users of, say, computer simulation techniques. So some of the collaborative computational projects have been doing that for a long time.
Okay, I see no further questions. Let's thank Robert again.
Great, thank you.